Section 10.3, Compound Interest. An investment is the use of money or capital for income or profit. In a fixed investment, the amount invested as principal is guaranteed and the interest is computed at a fixed rate. In a variable investment, neither the principal nor the interest is guaranteed. Compound interest that is computed on the principal and any accumulated interest is called compound interest. Here's the formula for compound interest. A is the amount that accumulates in the account, P is the principal, R is the interest rate as a decimal, and T is the time, and N is the number of compounding periods per year. One difference between this formula and the simple interest formula, in this formula we calculate the accumulated amount, not just simply the interest. In the simple interest formula, we simply calculated the interest that would be earned. Determine the amount accumulated and the interest earned if we took $4,000 invested for 2 years at 6% compounded semi-annual. So in this case, the principal is $4,000, the interest rate is 0.06 as a decimal, 2 years, and semi-annual means 2 compounding periods per year. So we're going to take those values and put them into the formula. The first thing we're going to do is simplify within the parenthesis, and the first thing I'm going to do is take the 0.06 and divide by 2, and I get 0.03. And then the next step, if I had my calculator here, I would go ahead and add that 0.03 to 1, and then I'm going to raise it to the exponent, 1.03 raised to the 4th power, and I get this number here. Now in my calculator, I would never stop. I would continue with the calculations. I wouldn't stop and write down any intermediate steps. And then finally, I would multiply by the principal of $4,000. So at the end of the 2-year period, we would have $4,502.04. And the interest, remember I said before, this is the accumulated amount. In order to calculate the interest, we would subtract off the principal, and we see that we would have accumulated $502.04 in interest. Kathy invested $3,000 in a savings account with an interest rate of 1.8% compounded monthly. If Kathy makes no other deposits in this account, determine the amount in the savings account after 2 years. So she put in $3,000. The interest rate as a decimal is 0.018. Compounding period was monthly, so they're 12 per year, and she put the money in for 2 years. So we go ahead and we put the numbers into the formula. And again, the first thing we're going to do, let me just go back for a second, is simplify right here in the parentheses to take 0.018 and divide by 12. And then we're going to add that to 1, and then we're going to raise the 1.0015 to the 24th power, and then we're going to multiply by 3,000. So at the end of the 2-year period, she would have accumulated $3,109.88. The annual percent yield, or annual percent effective annual yield, is a simple interest rate that gives the same amount of interest as a compound rate over the same period. So we're comparing now the compound rate to a equivalent simple rate. So determine the annual percent yield for $1 invested for 1 year at 2% compounded quarterly. So here's our formula. We're going to put in quarterly is 4 periods per year. Interest rate was 0.02. So I simplify inside the parentheses first, divide 4 into the 0.02, add it to 1. I'm going to raise that to the 4th power. And then finally, the last step I have to do is subtract 1. So a 2% interest rate compounded quarterly is the same thing as a simple interest rate of 2.02%. The APY is always going to be slightly larger than the quoted compounding rate. The present value formula, this is where we want to calculate how much do we have to put in currently in order to accumulate a certain amount of money. So this is the principal to invest now. A is the amount we want to accumulate. R is the interest rate as a decimal. N is the number of compounding periods. And T is the number of years. So Will would like his daughter to attend college in 6 years when she finishes high school. He would like to invest enough money in a certificate of deposit now for his daughter's college expenses. If he estimates that he will need $30,000 in 6 years, how much should he invest now in a CD that pays a rate of 2.5% compounded quarterly? So we're going to use our present value formula. We want to accumulate $30,000. 0.025 is the decimal interest rate. Compounded quarterly is 4 per year for 6 years. So we're going to go ahead and put our numbers into the formula. Again, we're going to simplify inside the parentheses first. So I went ahead and I divided Let me flip back for a second. Took 0.025 divided by 6 and added 1. And then I'm going to raise that to the 24th power. And then finally, I'm going to divide that value into the numerator of 30,000. And so Will needs to invest approximately $25,833.30 now to have $30,000 in 6 years. You have a choice of taking simple interest on $100,000 invested for 2 years at a rate of 3%, or the interest on $100,000 invested for 2 years at an interest rate of 3% compounded daily. Use 360 days. Which investment earns a greater amount of interest? Give the difference between the amounts earned by the two investments. So first we'll do the $100,000 in simple interest, with simple interest. So we use our simple interest formula and we would accumulate $6,000. Now we're going to do the compounded formula. So here's our formula here. It's a 3%, 360 days. It's compounded daily. We go ahead and simplify inside the parenthesis. We get this number here. We're going to raise it to, it's 2 years daily, so 720. And we come up with, now again, this is the accumulated amount. So in order to find the interest, we need to subtract the amount invested, which was $100,000. So here we'd earn $6,183.39. So simple interest was $6,000, compounded interest was $6,183.39. So the compound interest is better. It earned $183.39 more than the simple interest.